All right. All right. So here we go, guys. Yes. You know what? I think what somebody did when your notability is not working is they kind of reset their, they just restarted their iPad.
Okay.
All right. If that doesn't work, you can just take notes on pencil. I think that will correct it, but I'm not sure. Okay. And then again, I don't want you to worry about it. All right. If it, just reset and see and just kind of pay attention. All right. That's why I like recording. So if something happens, you can go listen if you feel like you missed something. All right. But let's go ahead and finish up here. All right. Because we got a little behind yet, not behind, but I was a little slower yesterday. So we need to define all the numbers that we're going to talk about this year. So the first thing I want to do is we're going to blow this up a little bit. And can someone tell me, does anybody know what the natural numbers are?
I forgot. Sorry.
What is that? That's okay.
Like numbers going up from like not decimals or fractions, just normal numbers.
Where do they start at?
0.
Where do they start at?
1.
1. Yes. So natural numbers are this, guys. 1, 2, 3, ... Notice I don't see a decimal. I don't see any fractions. So natural numbers, believe it or not, is where they used to start counting. All right. They didn't know about fractions. They didn't know about negatives. They didn't know about zeros. So they started with the number 1. All right. Then eventually they discovered the number what? 0. So they gave that a new classification. They started with the whole number. Oh, by the way, natural numbers, we're going to abbreviate as a what? N. Whole numbers start with what now?
0.
0. So we got 0, 1, 2, ... And that would be whole numbers. Everybody okay with that? All right. Now, from last year, what's an integer? You guys counted with integers last year. What was it?
I think it's like all whole, negative, and positive numbers.
You are exactly right. They're whole numbers and they're opposites. So here's how you write that. ... -2, -1, 0, 1, 2, ... And obviously you would label the integers what? No, are you? Well, obviously you would name integers what letter? Man, you guys, I can't believe you didn't know this. Z. That was so obvious. How did you not know that? Believe it or not, yes, I have no idea why. All right. They decided to call integers what? Z. All right. So if you want to abbreviate integers, we call it Z. All right. Part of the reason why we don't call it I is because there's a thing in math called imaginary numbers. All right. You learn that when you go to high school. All right. But right now we just know real numbers. So now, what are we talking about when we talk about rational? What's a rational number?
Like decimals?
Oh, I like that. Oliver's in the game. Thank you, Oliver. He is correct. They are decimals. But what else? Specific kind of decimals.
Whole
What?
decimal?
Now,
Oh, yeah,
Look-
possible.
let's look. So what I want to try to show you is this. I want to try to show you that. What's the root word for rational? Ratio. So what does ratio mean? Fancy word for what? Fancy word for fraction. All right. So what is exactly a rational number? A rational number is any number that can be written as a fraction. Any number that can be written as a fraction. All right. That is considered a rational number. So is a natural number a rational number?
Yeah.
Yes, because I can say 1 is 1 over 1. That can be written as a fraction. So bear with me.
Yeah.
All right. So if any number that can be written as a fraction, what number can't be written as a fraction?
Decimals that go on.
Decimals that goes on. So for example, let me ask you this. Are you telling me that 0.3 repeated is irrational or rational?
Irrational.
Why not?
Because it's 1/3.
Yay, very smart, because it is 1/3. Very smart. All right. So you're kind of true. It does go on forever, but it can't what? Repeat. All right. So an irrational number, I want everybody to write down, is any number that cannot be written as a fraction. Any number that cannot be written as a fraction. So rational is any number that can be written as a fraction. Irrational is any number that cannot be written as a fraction. And then, of course, I'm going to give you examples. All right. Now, I know some of you guys learned last year about repeated decimals. And we already determined that repeated decimals are rationals. What about decimals that terminate? For example, like 0.5. Is that a rational number? Rational, because 0.5 is what? 1/2. Everybody happy with that? Right? So generally what we say is if it repeats or terminates, that decimal can be put as a fraction. Now, if I said something that repeats or terminates, what's left? Something that doesn't what? Doesn't repeat or doesn't end. All right, so what is an example of that? For example, pi is an example. Why is pi an example? Because pi is 3.14159, I think 627, 267. I think that's what it is.
That's 2693.
Okay, thank you. So then it goes on. Now I'm asking you this. Shh, shh, shh. This right here. Do these numbers have a pattern? There's no pattern. And do the numbers repeat? No. Now that doesn't mean the number can't occur again. It just means it's not going to come up with a sequence that repeats. All right, is everybody okay with that? Now let's look at this number. Square root of 4. Can somebody tell me what the square root of 4 is? What is it? Tell me. 2. What's the square root of 25? 5. You guys learned that last year, right?
Oh, whenever time by itself.
Yeah, that's right. So is the square root of 4 a rational number? Yes, because you can take the square root of it. Is square root of 25 rational? Yes, it is. All right. Now I'm going to ask you about this number, square root of 3. That's not a perfect square. So that's in the category of an irrational number because the square root of 3 is like 1.71 and then it just goes on and it doesn't repeat. All right. And then there's one really famous number, Euler's number, E. All right, that's another famous, you haven't learned about that yet. You'll learn about that in Algebra 2. But pi is irrational and E is irrational. All right, and E is called Euler's number and it's approximately 2.718, ... All right, you learn lots of things about that, all right, in the future. All right. So now there you have it. Rational, any number that can be written as a fraction. Irrational cannot be written as a fraction. And then real numbers are, guess what? Real, that's right. They're alive. No, real numbers are all these numbers. All right. So every number is a real number until you get to Algebra 2, and then you'll learn about what? Imaginaries. Thank you very much. All right, imaginary numbers are not real. Anybody have any questions with that?
Basically, everything is a real number.
Everything is a real number. All right, exactly. All right. Now I'm going to ask you a question. Please listen, and this will help you. If you are a natural number, you are also a what? Whole number. You're also a what? Integer, and you're also a what? Rational. Every number is real, so we don't have to worry about that. If I am a whole number, do I have to be a natural number? No. I don't. But if I'm a whole number, am I an integer? Am I irrational? If I'm integer, I'm irrational. Does everybody agree with that? So it's like you're flowing down. All right. So if I'm an integer, I'm also a what? I'm also a rational. All right. Is everybody with me? All right. If you start at a rational number, do you have to be an integer? Going backwards is not necessarily true. All right. But going down is what? Always true. Can you be a rational and an irrational number? No, you cannot. You can't be both. All right. So if you're rational, you're not irrational. And if you're irrational, you're not anything else except real. Is everybody happy with that? All right. Now, I'm sorry about yesterday. We kind of rushed, but now I have the worksheet. All right. So let's take a look. Let's see how much you remember. All right. So here we go. I'm going around the room again, trying to figure things out. So help me out, Liam. 3 plus 4 equals 4 plus 3. What property is that? And if you need to sneak back and look, you can. What is it? Yeah, commutative property. That's okay. And it's addition. All right, it's addition. You can abbreviate. All right, where's Tanner? All right, Tanner, tell me, what do we got?
Associative.
That's correct. Associative property of?
Multiplication.
You're awesome. Thank you, Tanner. All right, let me have no Catherine and no David. Andre, what do you think? Yep. Of, if you multiply by 1, but we say multiplicative identity. All right, multiplicative identity. Anytime you stay the same, you are an identity. All right, Aiden, tell me what I'm doing with 49 plus 0 is 49.
Oh, that would be the. Yeah, that's the additive identity.
Yes, that's the additive identity. Thank you. All right, Oliver, you're up, buddy.
Okay. That's the additive in wait,
Yes.
no, it's
You're right.
the additive inverse, yeah.
You are right. Very good. Additive inverse. Remember, inverse is when you're canceling out. Inverse is when you're canceling out. All right, now we have Mr. Lackman going to jump in now too. So what's 6? This one's a tricky one. Notice what's happening. Things are what?
I think it's the.
Yes, you are amazing. Multiplicative inverse. That is correct. Very nice. All right, Sophia, help me out. Number 7. Now look, there's no parentheses over here, right?
Yeah.
So it's kind of a tricky one. Look at number 8 for me. What is number 8?
Number 8 is.
Look down a little bit. You were going to do this a bunch this year, so you're going to get it. It's the distributive property.
Oh,
Do you remember that?
Yeah.
So 7 and 8 are both what? Distributive. I just did one with a variable and one with not a variable. You with me on that? Now, again, to me, it was always easy because, you know, associative, they had to be parentheses in both ones. Do you agree with that? All right. So we have both of these. Don't be afraid. Distributive property. All right. Abigail, tell me about number 9. Yes, multi something. All right, we're not going to say multiplicative too many times. All right, so we're going to do the multi, and then we'll do a decimal. We'll do a period to abbreviate, and then we won't have to worry about it. And then multiplicative inverse. All right, or inverse of multiplication. Do I care about the words? No, I care that you understand it's an inverse. All right, give me Court. Where are you at?
Here.
All right, Court, tell me about 10.
The additive property.
Additive what though?
Inverse.
Are you canceling out or are you staying the same?
Same, same.
So it's additive. Yes, additive identity. All right. Colson,
That would be commutative
that's
property.
correct. Very good, buddy. Now, where's Cooper?
Right here.
Tell me, Cooper.
Is that the associative property?
You are correct. Associative property. All right, notice the order is the same. All right, parentheses are different. All right, Katie,
It'd be the additive inverse.
additive inverse. Did I say that right, Katie? Or is it Kate?
Okay.
Okay. phew. Additive inverse. Yes, sir. You got a question?
11 is associative, right?
I didn't say that.
Oh. I missed one.
We said 12 was associative.
Okay.
You back on track now?
Yeah, no, I just missed one.
That's all right. It's totally okay, guys. Mistakes are totally allowed in here. All right. It's important to get it right. So if you're not sure about something, just speak up, just like you did. And I'll just tell you where you made your mistake and we'll move on. Good with that?
Yes.
All right. So now, uh-oh. Kyla, I got it right, didn't I?
Yes.
All right.
So would that one be the associative property?
You are amazing. Associative property. And I would just put addition. Yes, sir.
Can you go over that one?
Oh, why is it associative? Because parentheses are changed,
Oh, okay.
right? The order is the same, 4xyq, 4xyq. The only thing that's different is, right? So again, what they're saying is that if you have three numbers and you're trying to add them up, does it matter what numbers you add first? And that's what they're telling you. Okay? All right. Brianna, tell me.
The associative property.
Oh,
Oh, sorry.
don't be sorry. Don't be sorry. Yes, you are amazing. That is correct. See, everybody has trouble with multiplicative. All right, that's why you don't have to say it. Multiplicative inverse. All right, Sebastian. Tell me about 16.
This will be the associative.
Are you sure?
Yeah, that is a. No, that will go coming.
Are you sure? Shh, shh, shh. You're supposed to say yes. Right, you're right. It is commutative property. Just because I ask a question doesn't make it wrong now. I'm trying to see what you know. And if you're brave or you're going to be wimpy and say, oh, I don't know. No, stick with your answer. If you think you're right, you're right. All right. Now, he is understandably that it looked like I was trying to trick you because there's parentheses, right? But the first thing you do is you just say X, Y, Z, uh-oh, it's out of order. So as soon as something is out of order, it's called the commutative property. Loud and proud. That's right. Even when you're wrong. All right. Here we go. Brooks. What is that?
I can't forget.
That's okay. Just say multiplication. Now, are we canceling out? So go back to your properties. I think it's the very last one, if I'm not mistaken. Why is it the zero property? Well, not exactly. What does the zero property tell you? Anytime you multiply by zero, you are a what? You are a zero. Thank you. Brooks, is that okay? All right. Yes.
Can rational numbers be negative?
Yes. Right. Negative 1/2. True. All right. Walter. Tell me about 18.
Okay.
Don't mess it up.
Additive inverse.
Wow, additive inverse is correct. All right, 19. Carter,
The distributive.
that's
property?
correct. Distributive property. And Liam, what is that? Why? Shh.
Oh, wait.
That's all right. So tell me.
Associative property?
Yes. Now, some people call it commutative. Some people do actually. But I'd like for you to think of it as like, has anybody heard the word commute, back and forth to work? That's kind of what it is. It's the commutative property. All right. And I like to remember it because commute means going back and forth. So I think of it as order. All right. The order in which you add makes no difference. All right. So with that being said, yes, sir.
If there were like 25 squared, like the answer is 5, would you go off that or would you go off 25 squared?
I don't know what you're asking.
What's the square root?
Shh, hold on.
So like, if 25 squared is 5, would you?
No, 25 squared is 625. Do you mean the square root of? All right, I'm sorry. You see, I was confused. Square is a number 2. So square root of 25 is 5.
Yes.
All right, I know what you're doing. You're asking me about the rest of the work. All right, you're working ahead. All right, I'm going to get there, I promise. Here we go. So now I'm at Tanner, 5. Tell me about 5. Well, first of all, everybody just going to mark off what? Everybody just mark off real if you want. All right, now, Tanner, what is 5?
So 5 is a natural number,
Yep,
it's a whole number.
yep,
It's an integer.
yep,
And it's a rational number.
yep. You're amazing. Perfect. All right. Andre, tell me about -9.
-9 is an integer,
Yes, ma'am.
and it is
You're amazing. Perfect. All right, Aiden, tell me about -3.5.
It is a irrational number.
It is definitely rational. Thank you very much. You agree with that? Because -3.5 is the same as -7/2.
Oh, yeah.
All right. All right, Mr. Fogarty, you're up. What is pi?
It's irrational.
You are amazing. It is irrational.
Good job, Oliver.
All right, Sophia, you got the tough one.
It's a rational.
You are amazing. It is rational. Thank you very much. Now, do you know what fraction 92 repeating is?
No.
Someone who knows 92 repeat.
92 over 1, or 1 over 92.
Nope. Tell him.
92 over 100.
No, that would be 0.92.
Like 92 over like 10 with like a 0.
No, obviously 92 repeating is 92 over 99. Obviously. How did you not know that? What's the problem? How did you not know that?
We were testing how.
Right.
we were testing-
Now, let me show you something. What is 0.4 repeated? I'm going to teach you a bunch today. What is it?
Isn't it 4 over 9?
You are amazing. That's why you're in this class, 4 over 9. What is 0.6173 repeated? Don't embarrass me. Go.
9, 9, 9, 9.
Yeah, but you didn't say the numerator.
Um,
What is that? What's the numerator?
oh,
Oh, oh my goodness. Oh, we forgot. Numerator, denominator. You know how my 6th grade math teacher told me to remember that? I'm from Indiana, so it's Notre Dame. So you can always remember N is on top, D is on the bottom. Now you know. So now when we talk about Notre Dame, or you can think of it as the numerator and the denominator. All right. Stop. All right. Now, thank you, Mr. Hayes, square root of 5. It's not like something, it is something. What is it? Is not an answer. That's not a choice. Irrational. You are brilliant. That is correct. Irrational is good. All right. Abigail, tell me about 4 and 9/11. Is it? Are you asking me? Are you telling me? That's right. It is rational. Court, where are you? Court, what is square root of 25 equal to? 5. So it is what? Yes. What else? Yes. What else? Yes. Keep going. Is it irrational? No. Thank you. All right. Number 29. Where's Colson? Tell me. 9.1754021 ... What is that? You are amazing. Thank you for listening. -32. Give me Katie. It is integer and it is. You are amazing. 0. Mr. Lackman.
0 is not natural.
Not natural.
It's whole,
Yes.
integer,
Yes.
and it's rational.
You are amazing. Thank you very much.
Job.
Where is Miss Lopez with 0.198? What are we? Oh, I forgot somebody. Go. You say it again. It is definitely rational. Thank you very much. And I almost forgot Kyla. Oh, I almost said it wrong. Tell me what 9 is.
9 is natural.
Yes.
Whole,
Yes.
integer.
Yes.
Rational.
Right. Sebastian, where's Sebastian at? I don't want to pull a fast one on you, but tell me about 34. You got the tough one.
4 is rational.
That's it?
No, that's not it. It's also.
Are you sure? You're going with that answer. I'm giving you a chance to switch.
I think it's rational.
Why?
Because,
Is it natural?
yes, it can be natural.
Why?
Because you can make it 9.
Yes, thank you. All right. We got it. Thank you very much. So now I tried to trick you on that one. So 27 divided by 3, if you can simplify it, obviously you simplify it down to its most basic form, and that will then tell you that it was a natural. All right. Now, guess what we have here, guys? Extra practice. So now I'm going to stop the video and let you get to work. All right. But actually, I'm going to stop the video. Right. I'm going to pause it because I want you to work on this while I'm making an announcement.